And here we go. Today is about parent functions. What the heck is a parent function? Okay, a parent function is just a base, easy function that you probably have already memorized. You probably have already seen them before. And then we're going to talk about their domain and their range. So here's a typical one. You guys know that one? Well, if you really know it, you should be able to tell me both sides of the equal sign on this thing. What equals what? You remember it?
What equals what?
Apparently not. Who knows it? Nobody knows the equation for that. Really?
Is this y equals x squared?
What equals what? Very good. Y equals x squared. That's one of the parent functions. There's a bunch of them you're supposed to know. You guys, you recognize it now that you see it? Remember that one? You don't know that one. Okay. Well, this is one that is the most popular one for higher level math. Okay? It's the quadratic. This is called a parabola. And to find the exact points on it, you make an X and a Y chart. So let's do that together. My advice to you is pretty simple. If you have 5 dots and they were like this, 1, 2, 3, 4, 5, do you think you could have connected the dots? Yeah. Once you get enough dots, you're fine. So how do you get a bunch of dots? You make an XY chart. Everybody put in -2, and I would always start with that. And I would see what you get. What do you mean put it in? I mean put it in for the X. So this X here becomes -2. And then you take the -2 and you square it, and what do you get? 4. -2 comma 4 is one of the points. In fact, that's this one right here. Do you get how I'm getting these points? I'm sticking a number into the function. Ryan, give me another one that you think is logical. If I stuck in -2, what's another one I should stick in? 0, I agree. Leave a little room, though, because we should probably stick in another negative number. But let's put in 0. And I put the 0 right here. And what do you get when you put a 0 in there, Chucky? 0 squared is 0. And that's this point right here. Which one did you think I wanted you to leave room for?
-1.
-1 is correct. Everybody stick in -1, and we're going to find this point. -1 goes in here. And -1 squared is -1 times -1, positive 1. And that's this one. Do you get the idea? We're just going to find 5 dots. -2, -1, 0, 1, and 2. I would always find those 5 dots. Some people say find 3 points, but 5 points is better than 3 points. So if you get 5 dots, anybody in here can draw a line that goes through the 5 dots. Becomes really obvious. When you stuck in 1, what'd you get, Ryan? 1, 1. And when you stuck in a 2, Hazel, what'd you get?
4.
2, 4. And that's these last 2 points. This XY chart, once you graph those things, it's your best friend in graphing. You can graph anything with this. You might have no idea what the square root graph looks like, but you could immediately make an XY chart and stick in a few numbers. The first few are weird. Like, Josh, what's the first number I told you guys to put in?
-2.
Okay. Why is that weird? Because it's a square root of -2, and that there is no square root of -2. I'd say none. So that means it didn't work. That's not bad news. It's telling you that the graph doesn't exist there. So if I happen to know what this one looks like. Does anybody else know what this one looks like? You remember this one?
Looks like that, like negative numbers and square roots and stuff. Doesn't that have something to do with imaginary?
You are correct. So you can't. The thing is, you can't graph things that are imaginary. You're correct that square roots of negatives lead to imaginaries, but we can't graph those. And so in the context of let's try to graph this, -2, you can just say, doesn't work. How about -1? Also doesn't work. How about 0? That starts to work. Hint. The square root of 0 is a number. What is it? The square root of 0. What times what makes 0? 0. So 0, 0 is our first point. Yay. And then I can put in a 1. What happens when you put in 1? You have square root of 1. What is the square root of 1? 1. Because 1 times 1 makes 1. Now, you could go put in 2, but the problem is nobody knows what the square root of 2 is. Nobody. I'm telling you, they don't. Because it's irrational and it's a decimal and it goes on forever. Everybody can tell you about what it is. They can say, well, it's like 1 point something. But they were, in fact, you probably could get 3, 4, 5, maybe even 10 decimals. Some people probably have memorized it that far, but nobody knows all the decimals of the square root of 2. You can understand the concept of the square root of 2, but it doesn't work out nice. So let's not even use 2. Let's jump right to the square root of what? Yes, 4 is correct. Square root of 4. And the square root of 4 is 2. Now I've got at least 3 points on my graph, and that's good enough. You'll see it. Anybody remember this graph? Goes like that. These are so iconic that you're just going to be seeing them a lot. This year, next year, year after that, year after that. Depends on how long you take math. You're going to keep seeing these functions. Okay, so the parabola, this is just called the square root. SQROOT. The square root graph. If you forget it, you just make an XY chart. Figure out where the dots are again. All right, I'm going to tell you the big ones that you have to know. That comes up the most. That's a big one. Anybody remember one that was kind of a V shape? It's the absolute value. If I wanted to, I could make an XY chart, but I'm not going to because it's just super easy. If you put in 1, you get absolute value 1, which is 1. You put in 2, absolute value 2 is 2. You put in like -2. Do you get how if you put a -2 in, the absolute value of that would be 2, so -2 comma 2 is one of the points. All right, so this is where your dots would end up if you made an XY chart. Do you get that if you were a little kid who had such a bad memory that you could not remember your address? You just couldn't remember it, okay? Because you're a little kid. Do you get your mom would probably write it on a piece of paper for you to bring to school just in case you needed to get home? And if you were a little kid and couldn't remember it, like where do we live to get home? Well, you'd probably write it down, right? Well, if you, math-wise, can't remember this, you should write it down because it's that important. It's like one of those fundamental things. You just have to know that one. Do you get some kid might need a calculator for 2 times 4, but that's kind of sad. You're supposed to know 2 times 4 is 8. You know, like there's some basic ones. You just ought to know those. Do I expect you to know 2 times 74? Nah, not right off the top of your head. Maybe I'd like to think you could do it in your head, but I don't really judge you if you can't multiply a couple of bigger numbers together. Would I kind of judge you if you couldn't do 2 times 3? Yeah, that's pretty basic. You ought to know that. Well, in the context of this, these are the 3 basic ones, the most important ones. That one's absolute value. This one is square root. And this one is the parabola. Those are the ones that I think you really need to know. You should just know them. You should know what they look like without having to make an XY chart. If you have to and you forget, then make an XY chart. All right, so let's get into this. Do you remember that deal where this is like a function where you stick something into it and one input should only give you one output? if you put in a number 6 and it pops out with a 36, and later you put in a 6 again and it popped out with a 72, you'd be like, what the heck? That's not consistent. Most of you guys understood that for our test, right? Well, the domain is the things you're putting in. Now, can machines be poisoned? No. Can human beings be poisoned? Yes. And sometimes even by really normal things. Think of yourselves as functions. Do you get, I could feed each of you guys a peanut, and most of you would be like, fine, yeah. Some of you would like the taste. Some of you would be like, so whatever. And some people would actually die. Okay, so functions are like that too. Some functions are allergic to certain numbers. Like, for instance, the square root function. Do you get if you feed that a negative? It's going to die. It won't be able to do it. It'll be like, I can't exist when you say -6. There is no answer for that. So that's, domain is what you can safely feed the function. So the domain of this function is you can't feed it negatives. So how would I say that? I would say the safe things you can feed it start at 0 and go to infinity. That's called the domain. The domain is what you can safely feed your function. What can you safely feed a parabola? Y = x squared. Do you think you can feed that anything that would poison it? No, you can put in negatives, you can put in 0, you can put in positives, doesn't seem to care, gives you answers every time. This domain, you can feed it everything. It's like a kid that's not allergic to anything. I thought I was not allergic to anything until I finally got something and I had penicillin for the first time. And it's something that you take to try to get over some kind of an infection. So I took it, and I remember still, I was playing cards, and all of a sudden I looked down at my arm, and I was like, what the heck? I had big spots all over me, kind of like a leopard. It's like, what is going on? I had no idea what was going on. And I went to the doctor, and he's like, oh, you're allergic to what you're taking. You're taking penicillin, you're allergic to that. So I got leopard spots all over me. Thankfully, that's all it was. Some people find out that they're allergic by like, I can't breathe. And other people, anyway. So my point, there are some things you can't safely feed functions. This function, that thing can eat anything. This one, he has issues with negatives. Can't feed him any negatives. How about this one? Do you think you can feed that any number? Yeah, you can feed it anything. You can feed it negatives, positives, 0. Those are the main things you check. Just see if you can feed it negatives or positives or 0. All right. So the domain is what you can put in a function. I can put anything in that function. So it's domain, negative infinity to positive infinity. Question, Kai?
When you did the y = square root of x.
Yep, this one?
Does that parenthesis mean anything?
Yes.
Looking like that?
Yes. So I allow 0, and 0 works, then I put a bracket on it. If I had put a parenthesis on the 0, it would mean that 0 itself didn't actually work. So let me give you an example of that. Okay, so let's say I said 2 to 10. And this is the ages, I don't know if you guys know this, but you can have a daycare at your house with some rules. You can't have like 10 infants at your house and take care of them for people. There's limits. Like you can only have so many infants because they're really hard to take care of, and you might screw up. If you had 10 of them, you might end up like killing somebody because their kid was crying and, well, I don't know, needed you. Maybe it's choking on something and you're busy changing 2 diapers on 2 kids and it'd just be too many. So there's limits. Anybody happen to actually know how many infants you can have? You happen to know that one? 4. You can have 4 infants in your daycare. Otherwise, you're breaking the rules, okay?
Or it's like 4 infants per person.
Well, per person that's in the facility.
Yeah.
Okay, cool. So Do you get also, there's limits on like ranges of kids. So like I might say, you can have 2-year-olds up to 10-year-olds, but that's it. So your license as a provider might be that you can have a 2-year-old, but it's up to 10, and at 10, it's no longer okay. All the way, the kid can be 9.9 years old, but he can't be 10. So when it has a parentheses, that means can't be. And if it's got a bracket, that means it can be. And everything in between. So you could have 2-year-old, 3, 4, 5, 6, 7, 8, 9.9 even is fine, but as soon as they hit 10, you're not licensed for that anymore, and you got to get a different person to take care of them. Okay, so the parentheses and the brackets do mean different things. So this domain would mean the number 2 would work, and 3 and 4 and 5 and 6 and everything in between. All the way up to 10, but it can't actually be 10. All right, there's our halfway mark. All right, so that's called a domain. What's the range? Okay, the range is the things that come out. When you stick numbers in for the x, it's the y's that can come out. So let me show you what the picture would look like. So you remember this one, the parabola one? The domain is about the x values. Domain goes this way. The range is, somebody want to take a guess what I'm about to say?
Oh.
Yep. The range goes this way. Does this thing go forever in both directions? No. It's got a low spot. That's the lowest it goes. So the range on this thing would be from 0 to, actually, is there like a highest that it ever goes? No, it just keeps going. So we say infinity. And can it be 0? Yes, so I put a bracket. If it couldn't be 0, that means that the function gets really close to 0 but doesn't touch 0. All right, you getting what the parentheses and the brackets mean? Bracket means it works. Parenthesis means you can get really close to it, but you can't be it. So parentheses means get close to this number, but it can't touch it. Bracket means it can be that number. All right, so what's the domain of this one? Negative infinity to positive infinity. Everything works. It's what you can safely feed this function. And the range or the outputs, the things that are the y values, it's the y values. And the range of this one will be from 0 to infinity. All right, if you're really getting this well, you'd be able to answer this question. If that spot right there is at 2, 0, and this is the square root function, can you tell me the domain and the range? Tell me one thing you know about domain. Is it x or y? Is domain about the x or about the y? Domain is about the x. Range, therefore, is about the y. Does this function really go forever in both directions? And is therefore the answer negative infinity to positive infinity? Nope, it's not. Why not, Kai?
Because it starts at 2.
You're right.
So it'd have to be the bracket 2 to infinity.
And why a bracket? Because 2 works. If you stick a 2 in that function, it wouldn't die. It would give you a point. It works. And infinities always get parentheses. So domain is 2 to infinity. What's the range? Josh.
0.
Ooh, nice. A lot of people think it's 2, but he's right. It's 0. 2, what's the highest it goes? Can you do it, Josh? What's the highest this function would go if you kept going?
9.999.
Nope. This thing goes on forever. The square root function doesn't just stop at 10. It goes forever. I know you were thinking of that problem where I was saying, you know, that a certain daycare was limited to up to 10, but this is a square root function. It would go forever. So parenthesis here. Can you explain, Aiden, why that's a bracket?
Because it can be 0.
It can be 0. If I had to put a parenthesis there, it would mean it could get really close to but not touch 0. And it doesn't happen very often. There are times, though, when functions get really close to something and never touch them. It's called an asymptote. And you're going to learn more about those later this year. All right, so is this a function? Don't overthink this. Yup, it passes the what? Vertical line test. Domain is about the x's. Does it go forever in both directions? No. It's got dots. It stops. And then the range is about the y. We'll have to answer that in a second. But for right now, what's the domain? Don't say it, write it. And then compare it with the kid next to you. Everybody, try to get the domain of this. This is the part where you engage, and you compare it with the kid next to you, and you see if you guys agree. Okay, show it to the person next to you. See if you got the same thing as you. It'll be a good talking point. If you don't know, ask them. Okay, just to put to rest any debate, the furthest left it goes is 2, and the furthest to the right it goes is 4. It's how far left it goes and how far right it goes. And that was -2 to 4. And does it touch those spots? Yeah, bracket, bracket. There's the domain. How about the range? Everybody think for a second about what range must mean. Separate question here now. What is the range? What's the lowest this thing ever goes? I think that's the lowest spot it ever goes to. Do you guys agree? But it's not 4. A lot of people would put a 4 because they see a 4 by it. What's the lowest that it does? Vivian, what do you think the lowest it ever goes is?
-1.
Correct. 2. What's the highest this function ever goes? Is this the highest that it goes? No. That is. So Vivian, what do you think the answer is?
3.
And do I put brackets on these because they touch, or parentheses because they get really close but don't touch?
Brackets.
Brackets is correct. Who had -1 to 3 as their range? Cool. Process that now. Domain is left, right. Range is the low to the high. Are there a few functions I want you to memorize? Yeah, they're called parent functions. And here they are. Y equals x squared. If you remember, do you have a short-term memory? Write down the 3 big ones. That one, this one, and this one. Those are the 3 that I want you to have memorized. Recalling them right now and writing them down would help you memorize it. Know why? Because when you repeat something with some time in between, your brain goes, oh, so you've done that twice now. Do you want me to remember that? So wouldn't it be nice if you could just like click a button that says, remember this, and then you like say it to your brain and it would just remember it? I think someday we might have that based on some kind of an implant. I know it sounds crazy talk right now, but you heard it here first. Wouldn't that be powerful if you could just be like, encode a memory now, and then you do your studying, and then you hit at the end, and then you remember everything you just studied. That'd be powerful. Okay. I hope you said, that's x squared. Who remembered it? Okay, good. This is absolute value, V shape. And last but not least, that's the square root graph. You guys got those 3? All right. If you want, for extra bonus points, we might include this one later. So I'll just tell you now. That's y equals x, and anybody want to know what it is? Or do you know what it is? Want to take a guess? Yeah, you are correct, sir. X to the third looks like that. It's like a parabola on the one side, like half a parabola, and then the other side is like the other side got flipped over or something. And if you were like, how am I supposed to know what that is? XY chart, put in 0, you get 0. Put in 1, you get 1 to the third, which is 1. Put in 2, 2 to the third is 8. Put in -2, and you get -8. Put in -1, and you get -1. And you can graph all those points, and you'll be like, oh, I graphed 5 points, and it looks like that. It must be that function. Okay, they know everything. We already talked about the range of that one. Now this is talking about those parentheses and brackets that we already covered. Always use parentheses around infinity. You know why? Because you can't touch it. It's MC Hammer's favorite thing. Because you can't touch this. All right, parentheses around infinities. Domain and range of a circle. Yeah, you can do that. But it's not a function. You know why? It won't pass the what? Vertical line test. Good. The domain is how far left, right it goes. Left to right. Range is how far down to up. I know that feels backwards. But people do it backwards all the time. It's supposed to be the lowest to the highest. Domain on this thing, I hope you said it was -3 to 3. And the range on this thing, -3 to 3 again, actually. It was this way. And I'm assuming this circle touches 3, so brackets. If the circle got really close to but didn't touch 3, then I could go with parentheses. And it's not a function because it doesn't pass a vertical line test. All right. This one's a little too easy. I'll just talk you through it. Domain, well, it obviously goes both directions forever, -infinity to +infinity. The range is how low to how high. -infinity to how high? 4. And is it a function? Yes. But this one, this is your true test. Do you know what the function is? Don't say it, write it. Do you know what the domain is? And the range is? I'm going to pause for a second while you give that a try. So let's get that last answer in here. Domain. What should I call on here? I know you just got back, Lydia, but I bet you got it. You are correct. 1, infinity. Stella, do you know the range?
2, infinity.
Yep. Now I know that too. I know some people got that too wrong. Let me explain it. This point right here is clearly the important spot. And it's at 1, 2. And when you do the range, you want the y value. Okay. And now the function. Well, I could say yes, but then I'd be asked for more. What function is it? It is, and that's our 15-minute warning. And it is the square root of x function. But one more thing, if I really, really wanted to test you on it, I could say it's been moved to the right 1 and up 2. Do you guys remember these? The inside is the right and left, and this is the up and down. And look, it's been moved to the right and up, see? Now, I didn't ask you to do that, but do you understand what I'm talking about? It's like the parent function got moved right 1, and I know that seems like it's to the left, but you can't trust stuff on the inside. So the stuff on the inside is high, horizontal inside. The stuff on the outside is vertical on outside. I think I taught you those things, didn't I? I know it's been a while, but didn't I teach you that earlier this year? About which way things move, right and left and up and down? Or maybe I didn't. It's possible I didn't. I'm seeing a lot of people going, no. Okay, all right. Maybe I'm pushing too far then. Then maybe all I could have asked you for is, that is a square root function. Good enough. Okay. So, we're in chapter 5 here. The future units, just so you know, we're going to do quadratics, which are all about that square root function. And then we're going to do polynomials in the second semester. Polynomials are the ones that they make like kind of cool curves and stuff. And then rational functions are like fraction functions. And fraction functions make these kind of graphs. They have asymptotes, so they get kind of these cool curves to them. So this is an example of a fraction function, 1 over x. We're not doing that till second semester, but I will lose some of you for second semester. So at the semester, you guys, some of you are going to switch and move to a different teacher. And I really, really wish I could just keep everybody, because I've gotten to know some of you, and also because I think most of you guys are really rocking on your basics, which means you're going to do well the rest of the year. I'm going to get some people in here who haven't done anything on their basics, and they're going to really, really struggle. And you guys were smart, really took to that and learned those things. I know some of you are still a little lagging on those, but I'm telling you, it'll help the whole rest of the year if you could just learn those. And many of you have. I put up the scores the other day, and it was, holy crap, the basic 20 scores that had to be done in class under my supervision, the average score was like a 17 out of 20, and that's amazing. I wish I could get the first 20 scores up that high. But we'll keep working on it. Okay, and that's all I have for you today. Your assignment is going to be, we've already done all of these. Y equals x is a nice straight line. That one you probably knew from algebra. If you didn't know this one, maybe I should remind you. Y equals x, that's this line. We have graphed that a few times. You guys remember that one? Nice straight line, just a simple straight line. And its domain goes forever this way and forever that way. And its range goes forever and forever. Okay, and this quadratic one, we've already done that. And its domain goes forever in both directions. And its range, well, it starts at 0 and it goes up. 0 to infinity. Now you can move them around and then the range could change. And the absolute value is this one. And its domain goes forever in left and right. And its range goes from 0 to infinity. Because it's like this way. This is the range. Okay. Square root. That one, domain is from 0 to infinity. Touches 0. Range, also 0. That's how low it goes. 0 is the lowest it goes. And it keeps going up and that way, so it goes to infinity. So there's a little review. And you have a worksheet. There are a few people that are missing some tests. You get 2 weeks. After that, we're supposed to put in a 0. So I don't think anybody right now is in danger of like not getting credit for a test, but if you miss a test, you've got to get it done within 2 weeks. Same thing for retakes. If you bomb a test, you got a couple weeks. That's it. All right. That's all I got for you for today. I think you'll find the worksheet that's included in today's assignment to be pretty easy. I hope it is.